For a century, we operated under a very simple intellectual truce. Empirical science handled the measurements, and philosophy sat safely on the sidelines, commenting on the mysteries. But by 2026, the pressure of new technology broke the dam, and that neat arrangement completely fell apart. Look at physics. We hit the 100th anniversary of quantum mechanics with its central puzzle, the measurement problem, still wide open. Physicists are openly admitting that we don't need another interpretation. We need an entirely new approach. In artificial intelligence, consciousness went from a fun classroom thought experiment to an urgent engineering and policy dilemma in less than a year. And in biotechnology, we've reached the point where we can edit a human genome before society has agreed on what constitutes a person. Empirical science cannot solve these dilemmas alone. A microscope or an algorithm can't output an answer when the outcome depends entirely on how you define an observer, a self, or a conscious state. Our rapid technological push has accidentally stranded engineers directly on philosophical terrain. We find ourselves trying to build the future without the blueprints to define what it means to actually be an observer. The comfortable reaction to this crisis is to say science overreached, and it's time to humbly embrace the vague mysteries of the universe. That gets the history backwards. Philosophy's job was never to remain vague. Its actual purpose was to hold on to the hardest questions until we develop the tools to formalize them. The real solution is a reunion of the two disciplines. It is the exact moment when a foundational question becomes sharp enough to carry a numerical value. This operational framework is called ODTOE, the observer-dependent theory of everything. It takes those ancient debates and translates them into rigorous architecture. ODTOE supplies the missing mathematics, allowing us to finally treat reality, consciousness, and meaning as measurable physical quantities, rather than subjective moods. To see how this works, we have to start with the oldest question in the book: what is real? ODTOE answers this directly. Reality does not exist as a free-floating absolute. It is strictly observer-dependent, actualized only when an observer is present to interact with it. This scattered field of fluid particles represents the larger field H. When an observer interacts, a specific configuration, labeled psi, crystallizes from the chaos. ODTOE defines this transition as a mathematical rule, identifying when a possibility locks into physical fact. By tying reality directly to these observation equations, the quantum measurement problem stops being an embarrassment. It becomes a predictable, functional feature of the universe. That requires us to answer a secondary question. If reality requires an observer, what exactly is one? We have to discard the old assumptions. An observer is not a mechanical camera, passively recording data, nor is it an intangible soul. An observer is a specific mathematical topology, a strange loop with self-referential closure. Consciousness is not a simple switch, it's a hierarchy. As this loop gains internal layers, it scales up a vertical index called dimension d. That dimension, d, is a direct measurement of the richness and depth of the observer's self-model. As the science of 2026 begins to move toward dimensional frameworks to understand consciousness, ODTO provides the specific mathematical index needed to populate those models. The framework also tackles the concept of meaning. Rather than treating meaning as a human emotion about the world, ODTO defines it as a physical, measurable relationship. This formula shows coherence, written as BOC, measuring how an observer's self-model holds together. Energy sustains the loop, while doubt introduces friction. When energy and data quality increase, coherence tightens. If doubt spikes, the loop wavers. You might object that assigning letters to abstract concepts doesn't automatically make them scientifically valid. But ODTOE is bound by strict structural invariance. It relies on natural constants like pi and phi, the exact same geometry governing closed loops and sustainable growth in the natural world. Because the theory is anchored by unbreakable geometry, it crosses the line. It stops being a subjective story and becomes a rigid scientific structure that can be objectively tested and falsified. When we look back at the technological vertigo we face today, ODTOE offers 3 practical solutions. First, it gives AI, biotech, and physics a single shared definition of the observer, finally ending the contradictory debates. Second, it replaces vague policy checklists and emotional moods with precise, debatable mathematical quantities for consciousness and coherence. Third, it establishes an objective ethic derived from physics. We have a mathematical obligation to honestly increase coherence, rather than faking it with simulated data. This time of philosophers represents a shift in the very role of the thinker. It marks the moment the observer is written back into the center of our physical equations. ODTOE moves these questions out of the realm of speculation, anchoring the human experience in the exact same geometric constraints that govern the rest of the natural world.